Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, our present topic is mechanics of blending. In last session we have discussed that different types of fiber characteristics which affect the blending. Now, here at present we will discuss the how the blending is taking place at different processes like Blowroom blending, carding, and Drawframe. So, different stages the blending takes place. What is their mechanics? It is important to ensure that an intimate blending is required. Okay. So, our basic objective is to have intimate and homogeneous blend, okay. And for that we have to choose different parameters. So, one of the parameters as we have discussed that fiber characteristics, but in addition to that right methods of blending is important, okay. And their process parameters which is important, at which stage we should blend. So, blending, it is said that blending at the initial stage at the beginning like in Blowroom, it is actually it is preferable for homogeneous and intimate blending, but Blowroom blending has got some problems also. The constituent fibers should be arranged in random in the way that the in the different yarn cross section. So, that is important fiber. So, yarn cross section, in the yarn cross section, so this is suppose one fiber, so two fibers red and green. So, so if this be the case, so case A and case B. So, our basic idea is to have the yarn where constituent fiber in the yarn cross section are evenly blended, evenly mixed. Instead, the in case of B, the case is the situation is not like that. Here cluster formation is there. So, our basic idea of blending is to have the homogeneous distribution, okay, along the cross section of the yarn and the in the cross section and even along the yarn length. The ratio of blended fibers should be uniform at any cross section of the yarn. So, that ratio should be uniform. So, along the length also, so in this portion the ratio of blend proportion should be equal to the in the other portion also. So, at different portions, so it should be uniform. There should be no long term and short term irregularity in blend ratio of fiber. So, there should not be any in the lengthwise any variation. So, that we should be actually we should take care, and because these all are actually dependent on the fiber characteristics as well as the type of selection of blend mechanism. So, there are various possibilities of blending at different stages. What is this? That is a blend at a bell form. So, bell blending. So, blendomet by Trusler is a very popular method where the fibers are actually collected directly from the bells and it is mixed together. From different bells the fibers are continuously collected plucked and it is blended. Flock blending. So, the feeding blending, or it is called stack blending. So, we form the stack of fibers, and then so different stacks are there. Okay. Fiber stacks are formed, okay, and the fibers are taken vertically. So, in this fashion also blending takes place. So, different stack blending or feeding blending. Lap blending is also there, although nowadays lap does not exist in most of the Blowroom line. So, lap blending is also there, which where uniform blend is possible at the carding stage. Sliver blending, it's in takes place in the Drawframe. Okay. Sheet blending, okay, in the sheet form it is blending takes place, maybe in the in your scatcher we use this one. Stock or combed sliver blending. So, stock means in that polyester fiber, when we mix polyester fiber with cotton, we use cotton combed cotton sliver, combed cotton sliver. So, combed sliver, and it's blended with polyester. Polyester and normal cotton without combing, it is normally not used in the Blowroom, because of the fact that their short fibers are there. So, we have already discussed combed cotton fibers are taking here, but the problem here is that the fibers, cotton fibers are carded twice. So, this may damage the fiber, fiber loss will be there. Okay. Now, you can see the process sequences. As we have discussed, this is for carded variety, carded cotton variety, and combed cotton variety. There are two types of blending we can have, either in the carded directly the cotton we can use, and then combed variety where we want to have superior quality of product. Now, flock blending is there. Cotton and polyester, they are processed in bale opening separately. Separately we open the fibers, then we it goes through the metering devices where the fibers are weighed separately. Okay. Cotton and polyester fibers are their weighed separately, and then they are actually mixed. Separately we are blending, bale opening is there, because the polyester and cotton, their actual compactness are different, their trash contents are different. That cotton goes harsh cleaning action, polyester does not need. Polyester simple opening is important, is needed, that will be enough, but in case of cotton the little bit harsh beating is there to make it open, and then we blend, we actually weigh, we meter depending on our blend proportion. If it is 50-50, then equal quantity is mixed, then it goes to primary opening. After mixing, the primary opening is there, then another opening where is the blending is, it is called blender, blending is there, then fine opener is there, then next is final opening, then contimeter is there, that means it will be actually there will be weighing, final weighing will be there. Next is that contimeter blend, like is using carded one, where polyester and cotton, they are separately processed. Okay. separately processed, and then at the contimeter where it is actually separately weighed and blended. Now, you can see here for this cotton we need preliminary opening, in polyester we do not need preliminary opening, and then through blender, that is another beating. So, it is actually blended at the later stage. Okay. And for sliver blending it is for draw frame. At the draw frame stage, okay, the polyester and cotton, they are processed separately depending on the different types of beating, and at the sliver stage, the draw frame stage, it is blended. For combing, for combed blending, the cotton is processed, okay, and polyester is processed separately. Carded sliver blending, the sliver blending, that the carded and carded, it here combing is not there, but they are processed separately and it is blended at the draw frame stage. So, in the next picture will be continuation of this, you can see. Now, the process stage, now carded, you can see that it goes to a contimeter, means it is just before carding, that it is going to final opener, then here the carding will be there, and after carding you can see the carding is there, polyester cotton, it is after contimeter, it is a blending is after blended ports fibers are there in the carding, which is shown by the crossing. Now, we can see here polyester cotton is shown at the right to left diagonal line, and polyester is shown left to right diagonal thing, and the cross means at this stage the actually blending takes place. Now, here you can see the at the flock blending, at the preliminary opening the blending takes place. So, the blended fiber goes, but and rest other cases the blending takes place at the carding contimeter stage, okay, at the carding stage or later. Now, here you can see the at the card, the contimeter was there. So, at this stage the blending took place. Now, flock blending here, then it goes to a draw frame, ring frame in this fashion. Now, in contimeter blending, it at the carding stage it is blended just back side of the card, at the back of the card, the in the chute feeding, that this blending takes place, and there then the process goes on, draw frame and carding. Now, sliver blending, if we see the sliver blending, polyester and cotton, they are processed separately, but and their draw frame it is blended, okay. And then here you can see the blending draw frame is separately used, and as it is blended at the draw frame stage. So, your the blend uniformity in the sliver is poor. So, we need additional draw frame. So, this is 3 draw frame passages are required, okay. But in case of the contimeter blending or flock blending, we use only 2 draw frame passages. Here 3 draw frame passages are required because of the fact that we need proper blending, because radial position of fibers are poor in case of draw frame blending, sliver blending. Now, in combed sliver blending, you can see here cotton is being combed, cotton fiber is being combed, but polyester is goes, because polyester does not need combing, and so it is combing preparation combing, and the combed sliver, cotton sliver is actually blended with the polyester at the draw frame stage. Again here 3 draw frame line is required, and card sliver blend where cotton and polyester is there, okay, and card sliver and polyester. Then it is blending at Drawframe blending is given here, okay. And then combing preparation and combing. So, here polyester is also being combed here, okay, along with the cotton. This is a retar process, and here we need typically one additional Drawframe, because we have already given another Drawframe stage, and then roving frame and ring frame as per requirement. So, these are the different mechanics of blending. Now, let us see their relative merits and demerits. So, carded flock blending, loss in good fibers, good polyester fiber due to same Blowroom line. So, in the Blowroom line unnecessary we are using the polyester fiber in the flock blending, carded flock blending. Carded contimeter blending is the improper card setting, because we cannot set the card both for polyester and cotton. So, polyester and cotton are fed together. So, carding setting is dependent on the type of fiber, because wear point selection and different types of setting. So, improper setting must be there, because we have to compromise. Sliver blend, combed sliver blend and card sliver blend, the retard blending, the chances of uneven blending is there, definitely it will be there, that I have discussed. Static charge generation due to separate carding. So, because polyester is carded separately, cotton is carded separately. So, polyester generates a static charge. Okay. Card sliver removal of high percentage of cotton in the comber. Okay. Comber definitely, because it is a comber setting will be there, and comber cotton fiber removal will be higher in case of in the comber. Now, blending at Blowroom. So, Blowroom blending is carried out by feeder blending. So, what we do here, we have the feeder blending, stack blending, lab blending. So, these three types of blending can be done in the Blowroom stage. Now, if you see the feeder blending, by feeder blending the different fibers are feeded to different hopper blender with feed adjustment to the required blend. So, 2 or more weighing hoppers are required. Okay. So, the different hoppers will be there, and then we just feed the material, and 2 kg fibers in each bale should be taken at a time, and blenders have to be provided with automatic weighing pan, so that it can deliver the individual component in metered quantities. So, there will be weighing pan will be there, and the fibers are fed, and the particular weighing plan, and after reaching certain weight. So, that is then it is blended. Sometimes it is done manually also. It is important that the individual feeders deliver the material with equal degree of opening to achieve the even blend. So, the feeders are there, and even opening is ensured. And different intensity of blending, it depends on the dispersion properties. Okay. We have to actually beat the fiber. So, if the dispersion properties are good, then beating will be less, we need beating lesser beating. Degree of compactness. So, intensity of beating will be more if the tufts are compact. So, in a retar contimeter, the material is passed via feed chute and feed roller assembly to a short transport belt which acts as an electronic weighing device. So, electronic weighing device is there. So, the short transport plate. So, there actually in that belt their actual weighing takes place. So, this disperse different intensity of beating, actually it is if we try to use different fibers or different compactness. So, we must ensure that their intensity of beatings are different to get the final product final before mixing with almost even openness. Okay. Now, here this is the feed chute, here feed chute is there, and then feed roller, and this is here is the weighing device. So, weighing device is there, and then blending, it goes to the blending tank. So, here this ensured that proper blend percent is maintained. Metering is extremely accurate here in this method. Individual blend component pass through separately through respective contimeter. So, here we have to see that this is the say contimeter say, and here it is a separately for individual fiber the separate contimeters are there. The exact blend can be set by the control panel by setting speed. So, because we can set the exact blend by changing the speed of the feed. So, if we increase the feed, that blend percent will increase for that particular component. So, we can change the blend percent by changing the speed. Now, the stack blending. So, component fibers from the bale or opened pre-opened are weighed and laid down alternate layer. So, these are the different layers in this way, and about say this is about say 15 centimeter thick. So, at different thickness it is laid down with a large area around 40 square meter area. So, this type of stacking is there. So, different stackings are there. Now, from here we take the fibers vertically. So, height typically around 3 meter height, okay, and the horizontally laid stacks are then withdrawn vertically. So, we take the fibers vertically, that means this is component 1, 2 say 1, 2, 1, 2, 1, 2 like this, and if we take the it is vertically, if we remove it, then we can maintain the blend quantity, and this is done by both manual. Earlier days it is manually we used to do, now mechanized version has come in stack blending, that we will discuss. And this is the way this blendomet is there. Here you can see the fibers are arranged like polyester, cotton depending on our requirement, and the this plucking device it it takes the fiber from the top and it travels from the one side to another side, it travels and keep on plucking the fibers continuously, and to maintain, and that is why it maintains the blend percent. Lap blending, it is not possible for single chute cut. Okay. Single scatcher blowroom is not required, it is not possible. We use multiple scatcher portion, 3 to 4 laps from breaker scatcher is blended at the finisher scatcher. So, breaker scatcher is actually they use the lap, and now the finisher scatcher. So, there will be 3 to 4 such lap will be there, they will be placed in this fashion, and here after blending, after mixing, again final lap will be formed. So, you can see here this is the single scatcher where the blending is not possible. Now, you can see this is the breaker scatcher, sorry, breaker scatcher. So, here different types of fibers are they form the lap. Now, these 3 laps from the breaker scatcher is coming to the, this is the finisher scatcher. Finisher scatcher, and that from there this opening is taking place, and from after that again this scatcher lap, this is the final blended lap, breaker scatcher, and this is finisher scatcher. Okay. So, loss of fiber is low because separate blowroom line for different fibers. So, this is say polyester, this is cotton, okay. Say polyester, cotton, cotton, okay, and they are actually they come from the different blowroom line. So, polyester has got different blowroom line and cotton has got different blowroom line, and that is why the fiber loss is low, and only in the finisher scatcher we just open and then form a lap, and this lap is actually certain quantity is the fixed quantity is there because there is no loss, and finally the intimate blending takes place at the cutting stage. Now, blending at draw frame. So, normally used for binary blend. So, where only 2 components are there, say like polyester, cotton, we normally do not use this draw frame blend for tertiary or multiple blending, okay, component, multi component blending. Blend proportion is adjusted by number of slivers of each component and the hank of the respective sliver. So, we can change the hank if we want to keep the number of slivers same. So, number of sliver can be and if we keep the hank same, number of sliver can also be changed, like say 6 components, say 6 component we can have, say if we have 3 and 3. So, we can achieve say 50-50 or maybe say 4 or 2, 4:2, then we will achieve say this is 6. So, that accordingly we can calculate say 70-30 or something we can achieve, okay, 32 point something. And so, that way there is a limitation is there. Now, here we can achieve either 50-50 or say 70-30 close to that in this fashion, but if we want to get say 60-40 blend in the draw frame, in that case we have to take care of the hank also. If we adjust both hank of the sliver and number of sliver, we can change in this combination, we can achieve the very wide combination of blends. Okay. Large variation in blend ratio or very large variation in sliver linear density result improper blending. So, improper because sliver linear density there is a limitation. If we want to one is very thick sliver, another is very thin sliver, then improper sliver improper blending will be there, because sliver linear density we cannot have very wide difference. In that case drafting characteristics will be, drafting will be improper because of the thickness. So, that is a problem. So, there is a limitation. We can have to a little bit variation, but not too wide variation in linear density or blend ratio also. Difficult to achieve random fiber distribution, that is important, because after draw frame there is no such process which will actually achieve give the proper intimate fiber movement. So, higher index of blending is not there. So, due to lateral fiber movement is, so difficult to achieve random fiber distribution with a cross section of yarn. So, because of lateral fiber movement is actually not there, that little lateral movement. For other fiber cases like blowroom and carding, there may be some lateral movement of fibers from one surface to another surface, but here the fiber moves longitudinally. So, lateral movement is not there, or it is at very less. So, high index of blending irregularity is possible in case of Drawframe blending, but to eliminate these things we can increase the number of doubling. So, after repeated doubling and drafting, the blending is improved and it will actually it is near to random stage, but we need, because here the problem is that we have to use number of doubling. So, cost is increased. Now, we can see here the number of doubling, if we increase, then degree of mixing is increased. Okay. So, it is near 1 means it is random, to a close to random we can achieve, but here you will see this is one process, second process and third process. So, third doubling process we can achieve close to that, okay, at typically 0.9 we can achieve degree of mixing, but in Blowroom blending we can achieve easily the degree of mixing of 1. Now, let us discuss the merits and demerits of different types of blend methods. Feeder and stack blending, the merits of feeder and stack blendings are more intimate and homogeneous blend can be achieved, because it is at the initial stage. After that we have different beaters they blend, then carding process is there, in draw frame is there. So, blending is done at an earlier stage of processing, that is why we get more intimate blending. Only one opening line is required for constituent fiber. So, all the constituent fibers we need only one Blowroom line, that means your the installation cost is low, capital cost required will be low. Provides the simplest control on the use of uncovered fibers waste. So, it is a simplest control. So, we do not have to have different control system, require minimum manpower for blending. So, it is basically it is done at the initial stage, stack blending, and that is all. Once you do it, you do not have to control the fiber separately. So, this will go at the as a single fiber. At once we blend at the feeder stage or stack stage. So, after that the process goes as a single fiber, not blending. And demerits are there, difficult to attain uniform blend ratio due to clustering of fiber. So, once the fiber cluster forms at the beginning, so they do not get mixed. So, that we have to see, because at that stage fibers are not opened, like polyester and cotton. Cotton is not, suppose it is not opened, and at that stage, so that fiber will go in that cluster form, and it will get the fiber due the lump, it will be non-uniform blending. So, you will not get the uniform blend ratio everywhere. Final blend percent may change due to differential removal of fiber, that we have discussed particularly at carding. So, polyester cotton if we use, so cotton will be preferentially removed at the carding. So, that is why we get the fiber blend percent changes with the process. As all the components are processed like opening and cleaning, carding together, so certain degree of compromise is to be there at the process. Like polyester, if we dry, suppose we take example of polyester and cotton. Polyester will have different setting than cotton, both in blowroom, in card, everywhere. But as we are doing stack blending or feeder blending at the initial stages, so we have to have compromise. We cannot set as per the exactly as per the polyester or exactly as per the cotton, there is a compromise. So, optimum process conditions should be there, certain degree of compromise we have to get the we have to do, and to will get the compromised quality. But the better the merits is that it is a very simple one. Then lab blending is the merits of lab blending is ensure good blend homogeneity, easy to work, and good control on the use of recovered waste, because it is a fiber comes at the particular place, which is so that we can actually recovery is easy. Uniform blend ratio is obtained because superior to feeder blending and stack blending. So, because it is already opened in the blowroom, and then we are trying to blend. So, that because here cluster formation is chances is less. And demerits is the blowroom line has to be modified, both breaker and finisher sculpture has to be there. Most of the blowroom line, it has only breaker, only single sculpture is there, but nowadays this lab blending is not, does not exist in most of the modern blowroom lines. Setting on the card is a compromise between the optimum process conditions for each component separately. So, it is true for the lab for the feeder or stack blending, because similar to blowroom feeder and stack blending, because that setting is important. Polyester or cotton, if we set if we try to process in the carding together, then there will be compromise has to be there. Need proper control on lap weight. If lap linear density is changing, it changes, then it will affect the blend ratio, that proper control has to be there. So, cannot be used when the one component is very low, like 90-10, 80-20. So, for 80-20, so how will you blend? One, either we have to have say large number of feeder slide laps at a time, because 90-10, say if the linear density of each lap is same, if you answer, then we need say 10 such laps, 10 laps are fed. So, it requires a larger area, otherwise we have to have different laps of different linear density, lap weight, linear density, that is also, that will have some other problem, you have to set the lap weight. So, that is a problem where very low, one component is very low. blend of combed cotton sliver with polyester stock. This is another process. The many Indian mills, they prefer this blend in the blowroom. So, in the blowroom they use the polyester stock and combed cotton, so that it goes in the same line, carding line, but it has got merits. The process is very intimate blend. We get a very intimate blend because it is blending at blowroom stage, trouble free running and high card production, because already the cotton fibers are open, polyester are open. So, we can have high production, high card speed, and fibers are already carded, so combed. So, short fibers are not there. So, it will be trouble free, fewer imperfection, because already the combed cotton is there. So, better cotton individualization due to double processing in the card. So, cotton fibers are opened, are individualized very nicely, and reduced number of drawframe process. So, drawframe process as compared to drawframe blending, because already we have this is blended in the blowroom stage. So, intimate intimate blending is there. So, drawframe blend requires at least 3 drawframe presses. Here 1 drawframe presses should be enough, or maximum 2 drawframe presses. Okay. Lower end breakage due to fewer slabs, because we have already double carding. So, fibers are intimately opened. So, slabs will be less. Ease of recycling, 5 to 7% poly soft waste can be recycled. And now demerits of combed cotton sliver and polyester stock: poor quality in terms of tenacity and evenness, because due to cotton breakage. So, cotton is processed twice in the process. So, that it breakage of yarn evenness, and even sometime it increases the naps. Okay. Poor quality and tenacity and evenness drops, higher cotton naps are there due to reprocessing of cotton component. Cotton is processed twice through the carding. So, nape generation will be there. Not only carding, in the blowroom also twice we are processing. Additional blowroom and carding capacity is required, because we are same carding, cotton is carded twice, even blowroom is twice. Cost of production will be high here. Need extra space for stack mixing, because here we are mixing a card, not the bale where the fibers are compact. When we use mixing the fiber tuft from the bale, it requires a lower space. But when we mix the stack mixing in the combed sliver, combed cotton, it is actually bulky, huge space is required, because already it is opened. High waste due to double carding and blowroom. So, waste percent, so realization will be less, fiber realization will be less. Now, drawframe blending, the merits of drawframe blending is easier to obtain uniform blend ratio. We can adjust the blend ratio. During opening and carding, optimum setting of each components can be used. So, better quality of output with less damaged fiber. So, polyester and cotton, they are moving separately, as we have mentioned, and their settings are proper at their own respective stages, but here it is a better quality of output will be there, easy to work. Now, if we see the demerits, difficult to achieve random fiber arrangement in the yarn cross section, as we have mentioned, due to lateral less lateral movement. additional drawframe capacity is required, because we need at least 3 drawframe passage for drawframe blending. So, additional drawframe is needed, separate opening lines needed for each component, because it is going at the different line, because for polyester we need separate line, separate carding. So, we need different opening lines. So, that is all about the mechanics of blending, and in the next session we will discuss the one important parameter, and with the derivation we will do, which is blending delay time. Till then, thank you.